of our asset management series. We have a guest speaker today, so somebody more knowledgeable than those of us here at Duncan-Parnell, talking about wastewater problems and issues and how some of these Trimble solutions can certainly help solve and dialogue or interact with some of these problems. My name is York Grow. I manage our mapping and GIS product line here at Duncan-Parnell in our sales territory. And want to remind you that you are muted right now, and we'll keep you muted throughout the webinar, but please don't hesitate to use the chat window throughout the webinar, and we'll gather those questions and then give George an opportunity at the end to answer those questions. Also at the end, we will turn the ability for you to unmute yourself and certainly have a discussion with George on any of the questions that you do have. This webinar will be recorded within the next couple of days. Marissa Body, who's on this call as well, and our marketing team will then send out the recording as well as any comments from the chat window that have been answered. So you'll have that as a resource that you can pass along to other folks or just use for yourself to remind you what George has talked about with us today. So this is being recorded and will be made available at a later time as well. So with no further ado, I want to introduce George Elaro with Trimble Water. He's a little unique from some of the other Trimble Water folks we've had with us before, whereas George comes out of many years of experience in the field. In the manholes, we were with him with a client a couple of weeks ago in North Carolina, and he was telling me that he calculated one time, and I think he told me he'd probably been in over 200 different manholes. So definitely has lots of experience for what he's done, and I'll turn it over to him to kind of let you know a little bit about what Trimble has to offer. So thank you, George.
Thanks very much, York. I'd like to thank everybody for joining us today. So yeah, let me give you a little bit of background about my experience. I've been with Trimble for about 15 months now. I'm an account manager, and I assist all our partners with providing resources for solutions for wastewater applications, water applications. And before that, I have about 30 years of experience in the water industry. About 20 plus years of that was mainly in the field services, providing flow monitoring solutions, asset management system solutions, and other things, all to do with sewer systems, collection systems, pump stations, everything that you have to do with and you can work on out in the systems. I've probably been involved with that at one time or another. So with that, let's get started. So as you guys can see on the front screen here, Trimble recently acquired CityWorks probably about 2 years ago. So we've sort of implemented the CityWorks asset management system into our portfolio. And I work for the Trimble Utilities division, and we focus mainly on water, wastewater technology for solutions for those areas. And today we're going to be discussing wastewater system monitoring solutions. So let's talk a little bit about the history of Trimble and how they got involved in the water and wastewater systems. So about 5 years ago, 5.5 years ago, Trimble Water acquired a company called Telog. And Telog has been around since about 1984. They sort of pioneered the whole industry, IoT devices and remote monitoring before it was called IoT and remote monitoring. And they provided wireless, rugged, battery-powered sensors and RTUs, software and analytics for all your water and wastewater and environmental needs. So they really pioneered it. They're the experts in it. So that's how Telog has brought them in to help, back up the software and the technology part that we have here to offer. So what you can do with all these IoT devices, it gives you real-time situational awareness of all your assets that are out in the field. A lot of people have blind spots in their system. So having these battery-powered sensors and RTUs allows them to be able to put them just about anywhere where you have blind spots, where you don't have power, so you can't run SCADA and things of that nature. So that's where they're really useful in that area. We can get into manholes and wet wells where you don't normally run AC power and things of that nature. And this can help you guys with flooding, CSO and SSO and environmental impacts. You can conduct all sorts of wastewater monitoring studies. You can focus on your inflow and infiltration studies for your collection system, see where all your problems are, where all your headaches are caused. And then we also have other solutions for reducing leakage and non-revenue water for our water side of the industry. And overall, we help to streamline your management and your regulatory reporting as well. So let's get into some of the details as to the IoT devices that we offer. So this graphic here really shows you where we can place our RTUs and our sensors. Anywhere across the water and the wastewater side of things, as well as the stormwater. So today we're going to be focused mainly on the wastewater and the stormwater aspect of it. So everything we do helps you get, be proactive and help to detect all the issues that you have out there, whether they be CSOs, SSOs, flow monitoring, stormwater flows, pretty much anything that has to do with water in your collection system or in your stormwater system. We have an offering and a solution for that. We can start off with the rain gauge monitoring. That's a big part of most people's studies when they conduct anything to do with wastewater studies, I&I. They really need to have rainfall data to be able to compare that with the issues that cause your backups and your I&I situations. We can conduct open channel flow monitoring with our devices. Studies that are conducted for either I&I, capacity studies, hydraulic model calibrations, pretty much anything to do with studying a sewer system. We have a solution for that. As mentioned, we can get into sewer overflow studies and monitoring with a couple of different devices. And if you guys are monitoring your wet wells, your lift stations, your pump activity, we have a solution for that too. We have an RS system that is AC powered or battery powered that can slide right into there and accept different systems and signals from all your solutions out there. We're going to first focus on the collection system applications and how we offer IoT and technology to help monitor that. So this is a nice little view of everything we could offer in your collection system. As I mentioned before, most things will start with rainfall monitoring. So we have an RG32 RTU that gets connected to a tipping bucket and can provide you pretty much real-time data for all your rainfall activity happening in your system. We can conduct inflow and infiltration studies based on the flows that you're capturing during the wet period. And then with that, we can help you to identify and quantify your rainfall derived inflow and infiltration. We can also help you with SSOs and CSO monitoring as well. We can tie our equipment at flap gates or at tide gates in your system if you have a combined system, and we can check the events there and tell you when your flap gates are active and compare that to data that you're getting from your flow meter to see what sort of performance you're seeing out in your system. Our equipment also works well in billing applications. We have very accurate flow monitoring technologies to allow you to, check on all your billing situations, whether you're sending data or flow to another municipality, or if you accept flows from another municipality. We can track that and give you really accurate data to identify any issues that may occur there. And then when it comes to lift stations, we can monitor the sump levels, pump run times, any flow monitoring devices that you have at your pump stations. We can also track all the power usage on your pumps and any other devices and help you with monitoring your discharge as well. So how do we configure all this hardware to track your activities in your collection systems, and what can we track? So our workhorse of our RTUs is called the Ru-35. It's really well designed, very flexible, and has all sorts of capabilities to accept just about any sort of signal from any equipment that you have out in the field. We can take in mag meter flow. If you have some mag meters that you don't have visibility to, or if you have crews that have to go out there and check them, this way you can tie the mag meter into there. We can accept a signal if it has an output and tie that into our Ru-35, collect all that data and send it up to our Unity platform for review and for reporting. We can also track your gas detection. A lot of people like to see what's happening in their collection systems. They'll track either H2S and some other noxious gases in there, so we can check those levels, tie it into our RU-35, and send that up to Unity so they can be tracked remotely instead of having to send people out there to do manual inspections and sampling. We can also conduct level monitoring. A lot of people have some issues in their system, whether it be SSOs from fats, oil, and greases, or defects in their system. This helps to give you visibility to what's happening in your collection systems or your critical hotspot areas, and you can track that instead of having to send crews out there to manually inspect it. This way, it brings the data in. We can set it to alarm functions and alert you whenever there's any issues. We can conduct flow monitoring. What you see down there in that photograph is our Raven-Eye non-contact flow meter. That all ties into our RU-35, and you can conduct multiple studies with that for either I&I, capacity studies, pretty much anything that's needed to be tracking your collection system flows. We like to think of ourselves as a sensor agnostic. Trimble or Telog in the beginning found it really helpful to everybody, so you can accept any sort of signal from just about any sort of technologies you have out there. We can tie into a third-party salinity probes, conductivity sensors. We can attach float switches to it to give you level that way. And then we also can do some monitoring for your water quality zones as well. We can track pH, DO, TSS, pretty much anything that has a sensor that has an output. We can accept that into the RU-35, so it gives you visibility, gives you real-time data, and can also give you alerts and alarms as well, so you can see what's happening out there in your systems. And as well as that, we can also monitor your pressure gauges as well on force mains and other applications. So all this data gets sent up to our RU-35, and that data can be stored, and reports can be created, alarm settings can be set, and then we have the ability to send all that data from Trimble Unity over to our CityWorks platform for more detailed asset management solutions and studies as well. And another really useful attachment that we have for the RU-35 is that we can accept third-party flow monitoring technologies as well. All the most popular ones on the market, the ADS, HARC, ISCOs. We have connections and we have built-in software that it can accept a signal from all those sensors and monitors and send all that data up to our Trimble Unity instance so they can be stored and reported and tracked. We have a lot of instances where customers have had these other third-party units out there for years, whether it be their modems aren't working or they're outdated, and they want to just be able to use Unity to track all that data instead of having to buy a whole other flow meter. We have individual connections that can tie into all those three types of flow monitoring technologies and bring them all into Unity as well. So we'll get into a little bit of detail about the remote loggers that we have. And the first one we'll start with is the RG32A. It's a remote tail logger unit, and it can be hooked up to a rain gauge tipping bucket to give you rain data. So what is it? It's a rugged IP68 rated, self-contained single channel, whether it be pulse or event, wireless recorder. You can communicate with it through a communication cable through RS-232. And it also has the capability of cellular communications as well via our LTE modem. It's got a user replaceable 3.6 volt D cell battery. Nothing that's required that's special. We have those in house. You can order those, and they can be replaced by the user out in the field. And it has up to a 5-year battery life, depending on the call schedule. As you can see there, we can get up to 5 years of battery life with it if we're calling our data in twice a day. And obviously, it's remote monitoring for all tipping bucket styles as well. We offer a tipping bucket, but if you have your own tipping buckets, we can tie that into our RG32A as well. So let's talk about the hardware for flow monitoring and for level monitoring as well. So this slide here shows you what we have to offer as far as flow monitoring. And everything all starts with our Ru-35 logger. It's 4G LTE-M capable. And we have a non-contact flow monitor and velocity sensor. This is what you see up here in this diagram. It's our Raven-Eye. That can also be tied in with a level sensor, so you can do level monitoring as well. And we also offer an AV sensor as well that sits in the flow. So if you guys have applications where it's impossible to get the Raven-Eye in, or you just prefer the AV sensor, then we also have that option as well for you. So let's get a little more detail about the Ru-35 and what it is and how it works. So it's a rugged unit, and it's IP68 rated, so it can be installed in just about any sort of underground in a harsh environment. It was designed for sanitary sewers. It's got airtight connections. All the communication cable ports are all rated for submersion, and they can withstand just about any sort of scenario you have out in the field. So we can take up to 6 different sensors onto the Ru-35. We have 2 COM, 2 analog sensors, and we also can handle digital sensor input. And this is what supports our Raven-Eye 2, our ultrasonic level sensors, temperature sensors, our flow wave area velocity, and also our ultrasonic level. It's got a generic RS-485 Modbus communication, and it's got SDI 12 and 12C inputs from any third-party devices. It too can be communicated directly with a communication cable. It's also available to be communicated with a wireless Bluetooth connection. And as I mentioned, it's got a 4G LTE-M cellular modem as well. It's powered by 2 6-volt Lantern batteries, Rayovac. They're pretty much off the shelf, nothing special, no special batteries required to run the Ru-35. And depending on your application, we can get up to 4 years of battery life from the Ru-35 when it calls in twice a day. And if there are applications where you don't want to use a battery, we do have the options to power that with external power, 12 volts or 120 AC. And all the applications, as we mentioned, for open channel flow, pressure, level, and water quality monitoring. So we're going to talk a little bit about the Raven-Eye, what that is, in case people aren't familiar with that. So what the Raven-Eye is, it's a non-contact radar solution. And what that means for most of the customers is that it means lower maintenance cost, and overall the lowest cost of ownership for a non-contact sensor on the market, we believe. It's designed for just about any application you have out there in your collection system, in your stormwater system. Because of the range that the Raven-Eye has, it can be installed in really just about any conditions you have. It's got an ability to read up to 49 feet away from the flow itself. So you can get very flexible and very creative with how you install it. As long as you have a direct open access to the flow itself, we'll be able to get a velocity reading and a level reading. We have a plus or minus 5% accuracy, which is an industry standard for open channel flow monitoring. It can measure bidirectional flows. So if you have any sort of backup in your system, it helps to give you some visual as to how your system's performing under any certain conditions. It's battery powered, and we get up to about 15 months of battery life with our Raven-Eye hooked up to our Ru-35. When you're sampling 15 minutes a day and you call all the data up to our Unity platform twice a day. That's very beneficial to most people. A lot of the other flow monitoring applications, batteries last anywhere between 4 to 8 months. So just having the ability to run these things for over 12 months really helps to solidify the low cost of ownership for the Raven-Eye. We also have built-in internal diagnostics with the Raven-Eye. We have a built-in pressure, temperature, and humidity sensor. So if there are any issues with the Raven-Eye, if there's any sort of defects on there, we can track those 3 different measurements and set alerts and alarms into it so that you can be notified ahead of time before anything goes wrong with the sensor itself. And this last point is very important. We have a self-calibrating velocity radar sensor. We have a very unique algorithm that's been built into the Raven-Eye that's been developed over decades of data. So it always ensures that you're getting the most accurate velocity data when you're installing the Raven-Eye. We are the only manufacturer that can claim that. We hold a patent for that. So that really separates it from our competition when it comes to flow monitoring and velocity measurements. So let's talk about different applications for the RU-35 and what you can do for your manholes out in your collection system. So as I mentioned, it's got wastewater level monitoring, either using an ultrasonic or a pressure sensor. We can tie it into a contact and non-contact flow monitoring system. We can accept water quality monitoring as well, including conductivity. It's great for inflow and infiltration studies. It can take in third-party flow monitoring technologies as well. A lot of engineering firms who are conducting hydraulic model calibrations can use both our Raven-Eye and our AV sensor to help capture all that flow monitoring data so it can be used to calibrate hydraulic models. And as well as that, it can be used for capacity studies in your sewer system to help plan for capital improvements, upgrades in your system, just overall monitoring of your flows. So here are a couple of different instances of our equipment, how it can be used and how it can be installed and mounted into the manholes that you have out in your system. So the top center here is our AV sensor tied into a 15-inch band installed as part of a flow monitoring study for alarming and for SSO monitoring. And what you see down here is our Raven-Eye 2 installed in the manhole. And on the left side, we have a vision of what the RU-35 looks like when it's mounted in the manhole with an ultrasonic sensor measuring level in the pipe, and Raven-Eye as well, measuring some velocity. And on the right side here, here's what it looks like when it's set up out in the field, what the actual physical dimensions of it are. Here we have some photos of how the AV sensor can look inside the manhole. With all our AV sensors, we also supply the hardware to be able to mount the equipment into a sewer, whether it be in the pipeline or in the manhole itself. We have customized different size bands that'll fit anywhere from an 8-inch up to a 30-inch pipe. And that's what our Raven-Eye looks like in a manhole, mounted backwards and reading negative velocity, because that's how we found the most effective way to get accurate velocity readings. And because the Raven-Eye has a very unique mounting bracket, it's got pretty much a 360-degree ability to turn and twist with its mounting, with its double jointed ball and socket. So this application, we couldn't mount it directly on the wall in front of the pipe. So we're able to mount it off to the side and spin it 90 degrees and still get an effective reading. Here are just some more applications of how the unit can be installed. So an important part of all your monitoring applications is what you do with the data and how you review the data. So what we have available once you get all this hardware out there is to collect that data and send it all up to our Trimble Unity remote monitoring platform. We're not going to get into a lot of detail. I just want to show you just some overview of how easy it is to visualize what's happening in your system. So what we're looking at here is just a standard measuring report, and we've plotted the pipe height of this location. That's that solid blue line that you see along here. That's about a 30-inch pipe. And beneath that, you'll have the yellow-green color. That's our velocity. The red is our flow measurement. And the light blue down here is our level. You can see all the measurement units on the side. We have our flow on this side, on the left, and we have the level and the velocity plotted on the right side. So you can easily track it. see what's happening in the system, watch the performance. This is a normal dry weather pattern. So we can see the levels at about 20 inches and it ranges down to about 15. So it's easy to identify where you have issues and how your system's performing overall. And what we have here is just show you how easy it is to toggle through the different options on our reporting network. What we can do there is just simply click on the little table icon. And what that does is it generates all the actual numbers that we're seeing on our screen right here. So it shows the actual time stamp for each data point, our raw flow, our level, and our velocity, and our pipe height. So you can easily export all that data, whether you want to export a graph or if you want to send that data off in an Excel file, whether it be a CSV or an Excel file itself. That can easily be done, with a couple of clicks of the icons that we have up here in Unity. And this graph here shows you how quickly and easy it is to identify a problem in your collection system. We have a week's worth of data here, and first thing I see when I look at that graph is I'm looking at the pipe height, which is right around 30 inches, and then I track the blue because I know that's my level. And you can tell right around here on August 16th, for about 3-4 hours, that pipe was in surcharge. So that gives you real easy visualization of what's happening in your system, how it's performing. And if I had rain data, I can plot my rain data on here, and we can tell that there was a rain event on this day. And within a couple of hours of that rain event, the system started to experience a lot of inflow and infiltration, and that can easily be seen here. And as you can see, when the level increased and got over the pipe height itself, I know that my brown line right here is my velocity, so that experienced a backup and it started to slow down and cause a bit of a choke point in their system. A couple of days later, the same thing happened. There was a real large spike here. It must have been a pretty intense rain event, and you can track that the velocity backed up, went down below 2 feet per second. For the 3-4 hour period. So that's how easy it is and how user-friendly Trimble Unity's software system is. And all this data that you're getting, you can almost get real-time updates in your system, depending on how often you have the data sent up. So you can get live updates, you can track the alarms and overall health of your system. So let's discuss just level monitoring applications for sanitary sewers. So for our Ru-35, we have 3 different sensors that are compatible that we can use for tracking level. We can start off with a pressure level sensor. It's called our Telog PTDS submersible pressure sensor. And it goes from a range of 0 to 5 psi all the way up to 0 to 30 psi, which should be sufficient for just about any sort of manhole depth you have out in your collection system. There's our ultrasonic sensor. It comes in 2 different ranges. It comes in the 4-inch to 7-foot range. That's our 150 hertz sensor. It also comes in a 12-inch to 13-foot range. So depending on what sort of application you have, we have a sensor that could meet those needs. And as well, we can also use our flow wave area velocity sensor to track the level in your manholes. That has a built-in pressure sensor to calculate the level. And that can go anywhere from 0 up to 30 feet, so you can see what's happening in your system. So here's some different applications for our level monitoring. Obviously, we can help with SSO monitoring, alert you to when you're having some issues in your system. It can be used for lift station wet well monitoring as well. So you can see what sort of backups you're having, whether it be a pump failure or during wet weather. And for all collection systems supervisors and managers out there, this will also help to be able to track your hotspot. Instead of having to send a crew out with a combo truck to go out and flush that line and jet it, whether it be a monthly or a 3-monthly basis, you can actually track the level of the sewer remotely, instead of taking that time and taking those crews out of your production just to send them out there to flush the line. You can actually schedule your maintenance when you see the flow starting to rise in your system. You can also do some inflow infiltration tracking, not as accurate as open channel flow monitoring, but you can have several sensors out here in your system. You can track the difference between different manholes and try and identify and pinpoint where your inflow and infiltration is coming from. And also helps with operational prioritizations as well. And here are a couple of different applications that we have. First one here is our Ru-35 tied into a flap gate. As well. It's got a built-in pressure sensor, so they can monitor when surcharge occurs, when there's flap gate activity, so they can track the performance of their system. Here we have a ultrasonic level sensor installed in a sewer manhole just to track level. And then our ultrasonic sensor can also be used to measure flows at a flume or a weir. If you have a weir or a flume application, we can tie our UT35 ultrasonic sensor into one of our units and build a flume table for you, so you can get your flows that way as well. Okay, we're going to get into lift station and pump station monitoring applications with our equipment. First two photos that you see here just show you the capabilities of what we can do with our lift station monitoring. The photo on the left there is a wet well with some floats in there to measure the level. And on the right side there, we're measuring the level at a reservoir. And that is also equipped with a solar panel to give it power as well in case there's any sort of backup or any sort of power outage. So here's what we can configure and what we can measure at a lift station with our R systems. We can obviously track rainfall monitoring. We can also monitor gas detectors and gas levels in your pump stations and wet wells. We can use ultrasonic sensors to track your wet well levels. And with that as well, we can also tie into controllers that you guys have out there, so you can see what's happening with your controllers and actually have a backup to your SCADA if you need. One thing we don't do any controls. We just can monitor what's going on in the system, so we don't have the C part of the SCADA. We can just do the data acquisition. We can track pumps status and run times, and we can also track flow monitoring. So if you guys have existing mag meters out in your system, we can tie that into one of our units and get the actual signal from the mag meters and track those as it goes along. And as usual, when you get all that data, you have all that knowledge up there. So we send that all up to our Trimble Unit remote monitoring application, where all your reports can be tracked, your alarms can be set. And then we also have the ability to tie that into your CityWorks asset management system. So what do we use to tie in all the signals and different sensors and pumps at a pump station? We use our RS-33 system. Some of the things that we can sample are multiple pump run times. So we can get up to 3 different pumps with one of our systems. We can measure pressure. We can measure amperage, level, flow, and we have multiple digital or analog inputs. So the way our RS system works, it comes in 3 different applications. We have the RS-33. We can tie 7 channels, 14 channels, and also up to 30 channels of different inputs that we can get from your pump station. It's AC powered, and it also has a battery backup. So if there's any power outage at any of your pump stations, we have a small battery that's built into it that could run for several days if needed, depending on how many things you have tied into it. So you can still have visibility to what's going on out in your pump stations. And as I mentioned, we can run parallel with SCADA or as a SCADA backup, but we don't actually do the controls for SCADA itself. So here's what our RS systems are. They're multi-channel data recording, and they can take up to 8 analog or 6 digital inputs. That's for our 14 series. We can communicate with a RS-232 through a cable. It can also communicate with 4G LTE via the internet, and we also have the ability to communicate through an Ethernet or a landline if they're still out there. They have very low power consumption and requirements, so we can have a backup with solar as well, or some external batteries. And here's some of the power sources that we have available. Here are a couple of different applications of our RS systems out in the field. Top right corner here, we have a RS-33 tied into a level monitoring at a reservoir, and it has the solar backup panel. Top left-hand corner, we have an RS system here as well, monitoring an underground pump station. And down here, we have our RS-3314 inside a pump station, connected to all their pumps, their level monitoring for their wet wells, and tying into their power consumption as well. And here's another application of a below ground pump station, but we have all our equipment topside. They're all secure cabinets. They can be locked, so we can deter any sort of vandalism or any sort of theft. And as well, once you have all that data, you really need a tool to be able to decipher it and visualize it and track it and send reports out. So here we have an example of 2 pumps tied into a RS system. And along with that, we tie in the wet well level as well. So you can track your pump activity. You can tie it into your wet well levels as well, so you can make sure everything is running smoothly. There aren't any issues with backups or any sort of functioning with the pumps. And what you can also do with that is track the pump health and the activity. There are different ways to identify all 3 of your pumps at the same time. And then you can get all the run times and compare them to each other and see which pumps may be running inefficiently, which pumps may be about to fail. So you can really get a good visual of what's happening in your system to allow you to be proactive. And again, once we have all that data, after it's all installed and configured through the field application, whether it be the mobile app on your handheld tablet or a mobile phone, we can set up all the alarms and the events and triggers. We can set up all the KPIs, update your GIS system, whether it be through GIS handhelds or whether you're just going to import the system yourself. And as well, you can have the ability to analyze and report on your asset performance. It's got a lot of different dashboards and pre-built reporting all built into it. And here are some of the key features of Trimble Unity that we can get into. So as mentioned, you can have a system health dashboard. Provides you with you and your operational staff with real-time insights and to the availability and performance of your remote monitoring networks and your assets. You can create and manage telemetry reports, so you can track your units, whether make sure they're all calling in and there aren't any gaps in your system. You can also view, filter, group, and search for all different types of monitoring sites from your GIS map or a list view. You can review all your alarm conditions. You can change your set points and track the performance of your assets that way. And it gives you a high view of transit data if you're monitoring your water systems through pressure loggers. And you can also configure all your RTUs, create new sites, install new sites, whether you're relocating sites out in the field, all that can be done through our mobile app. It really gives you some flexibility in how you set up all your sites. And you can also view your telemetry data out in the field. So if you're out there at your monitoring sites, it helps you to identify any issues, and all that data is available on our Trimble Unity mobile app as well. And if you want to take it to that next level, if you guys have a work management system, all this data can be used to help populate that and helps you to dispatch work based on alarms and other performance indicators that you have tied into your system. And here's an overview of how that works. Once again, we get all our Trimble Telog remote monitoring data. We send it up to our Trimble Unity remote monitoring application. That can be tied into our CityWorks asset management systems as well. And that too can be sent over, and all the KPIs can be generated and help you with your operational insights through CityWorks. And all this sits on top of Esri GIS. We have a very good relationship with Esri. So all this is GIS centric. It helps you to be able to be aware of all your insights and analytics to be able to track and manage your system better. And that brings us to the end. I just want to say thank you to everybody for listening. Over to you, York.
Great, thank you, George. And if you all would like to unmute yourselves, you're welcome to do so now. If you do have any follow-up questions for George, there's one question that came in here relative to the RU-35. How long can you store data physically on that device itself in case it can't communicate up or for historical purposes? How long can it be stored?
Yeah, so it depends on obviously how many inputs you have, but if you're out there, you have a flow monitor with a couple of different sensors in there, you can get up to 5 or 6 months worth of storage inside the RTU before it starts to override. So yeah, you have several months of data capabilities there until you can repair that or get that data out.
Okay, great. Well, thank you. Any other last minute questions for George before we sign off for this time today?
Dante here. Going back to that question. So say I miss a call for whatever reason, like my network's down for a period of time and I've missed, my 2 calls or a week's worth of calls, and I want to recall that data without physically going out to the site. Can I do that?
No, you have to have the wireless connection up and running for that to happen. Otherwise, you'd have to travel out there and download that manually from the unit itself.
Okay.
Great. Any other questions? Well, George, thank you so much for your time today and all the great information there. We certainly look forward to getting it out to all of our customers that had signed up for the webinar today. With no further ado, we bid everyone a good afternoon, and thanks again, George.
Thanks, York, and thank you everybody for attending. It was a pleasure to be up here.